Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 1.6 notes where we are classifying polygons today. Alright, so let's take a look at these notes here. We're talking about polygons, some convex, some concave, some different vocab words here, and then we have some pictures and some examples of these polygons down here, as you can see. Alright, so we're going to talk about what those guys are. So as we're looking through those notes, we can ask ourselves, hey, what should our essential question be for today? So my first essential question is going to be, how do I classify polygons? So we're going to talk about today in these notes about how do we classify and how do we name polygons based on the number of sides that they have, as you guys can see here, the types of angles that they have, and so on. So we're going to talk about that today in these notes. All right, so let's take a first look here at polygon. A polygon is a closed figure of 3 or more sides that do not cross each other. Alright, so that is what we have for a polygon. It's a closed figure with 3 or more sides. As you guys can see down here, we have some examples of polygons, closed figures, and so on. Alright, so there's kind of 2 types of polygons that we're going to talk about as far as the convex and the concave. So a convex polygon has no side has a point in the interior of the polygon. So no side has a point in the interior of the polygon. So an example of a convex polygon might be something like, so we're going to have that as a polygon. It's got no points that are inside the interior. That all those points are on the outside, the farthest outside. All right, so now if we look at concave, that's kind of just the opposite. So it says there is a point in the interior of the polygon. Alright, so that means that this polygon has a cave in it. Okay, so if I draw a polygon that is concave, it might look like so. It's got something like this. So this point right here is inside the interior of that polygon. So this is a cave. That's what I like to look at it as. So it's a concave polygon. Alright, so 2 different types here. Either it has points that are inside it, like a concave, or it doesn't, like this guy, and it has no points in the interior. Alright, let's keep moving on here. We have equilateral. An equilateral polygon is a polygon that has all sides congruent. All sides congruent. Okay, so that means that all sides have that same length. Perfect. Equiangular, whoa, I can't pronounce that one myself. Equiangular is a polygon that has all interior angles congruent. So all interior angles congruent. Alright, so what that means is that we're going to look at some of these polygons that have some interior angles, and that means that all these interior angles are going to be the same. They might be 75 degrees, they might be 30 degrees, they might be something like that. We'll talk about those, see what those are. Alright, so a regular polygon is that it has all sides and angles congruent. So regular is a polygon that is both equilateral and it is equiangular. Equiangular. And U, that should be a U there. So if it's both of those, then it's a regular polygon. All right, so good. Those are kind of the definitions there. We're going to use those a little bit today in these notes. So if I look over to classifying polygons by the number of sides, we are going to look at how many sides each polygon has and what we're going to call it. Okay, so if you remember, you guys have seen this before, a polygon that has 3 sides here is, like, let's just say I draw a polygon with 3 sides. What kind of figure is that? That's a triangle. You guys have seen that before. Triangle. All right, that's the first one. If it has 4 sides, might look something like that. That is what we call a quad. Quad meaning 4, relateral. All right, so it's got 4 sides. It's a quadrilateral. All right, so now we have the next one. A prefix for 5 is going to be pentagon. So this gon goes with my polygon. All right, so it's a pentagon. All right, the 6, if it's got 6 sides, we call that a hexagon. Oh, I don't know where I went there. Where'd my screen go? There it is, hexagon. And moving on here, my 7, if I have a 7, we call that a heptagon. So Heptagon. Hepta meaning 7. Okay. 8 means what goes with octagon. So I remember 8 with octo. All right. Some people remember octagon. So some people remember that octo mom. She has 8 kids. She had 8 kids that were born at the same time. So if that helps you remember, that's good. All right, so 9 is a nonagon. It's Nonagon. So it's a nonagon. 10, if we have 10 sides, that is a decagon. All right, going on to 12 sides is a dodecagon. All right, so notice here we skipped 11 in here, okay, because 11 doesn't really have a fancy name. All right, so 11, and maybe this is like 13, 14, 15, 16, so on. Those are just called n-gons. All right, so it's an 11-gon, or it's a 13-gon. All right, so it's just those guys there. So these names of these quadrilaterals, you're going to need to know these guys. Going to need to know what these guys are called. Okay, so you're going to need to memorize that 5 is penta, 8 is octa, 9 is nona. All right, so you're going to need to know those guys. Have those guys down. All right, so now moving on to some of these examples here. It says classify the polygon by the number of sides. Tell whether the polygon is convex or concave and equilateral, equiangular, and regular. All right. So now let's go here. If I see how many sides does this guy have, I got 1, 2, 3, 4, 5. So remember, if we look back up here, we have 5 sides is a pentagon. So I'm going to write pentagon because it has 5 sides. And then you have to ask yourself, is this a convex or concave? Okay, so this guy doesn't have any caves in it, so it is convex. And then, is it equilateral, equiangular, or regular? Okay, so now we have to ask myself, does it have all sides congruent if it's equilateral? 1, 2, 3, 4, 5. Those dashes means that they're all congruent, so it's equilateral. Now you have to ask yourself, is it equiangular? So is all the interior angles the same? So all these little moon shapes here, these half crescents, tell me that they are all the same. So this is a regular polygon. All right, moving on to number 2 then. We have a polygon here that has how many sides? It has 1, 2, 3, 4 sides. So this is a quadrilateral. Right? It is a quadrilateral. Got 4 sides. Now you have to ask yourself, is it equilateral? Does it have all the same sides? No, because see how this guy has 2 up here and this guy has 2? That means those distances from here to here is different from here to here. Okay? So good. So it's not equilateral. Is it equiangular? No, this guy's got 2, this guy's got 1, so that means those are different. So it is none of those guys. So it is just a quadrilateral. Then I forgot here, is it convex or is it concave? There's no caves in this guy, so it is convex. Awesome. So now going on here, we have the last one. If I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So a 12-sided figure, if I look up here, is a dodecagon. All right, good. And then you have to ask yourself, is it equilateral? Are all the sides the same? Sure. It has all those marks in them to tell you that they're all the same. And then now you have to ask yourself, is it equiangular? And no, it is not, because here I have this angle, but here I have this angle. So those guys aren't the same. So this guy is just equilateral. And I keep forgetting this convex or concave. So if I go back to that question, is it convex or concave? Notice this here. These guys have caves in them. So that means this is a concave polygon. All right. So classifying these guys by the number of sides and by whether it's convex or concave. Good. So next one, sketch the following. A convex, so that means this one's not going to have any caves, nonagon. So how many sides does that mean? That means we have 9 sides. That is A, B, C, D, E, F, G, H, I. All right, so what I like to do is I just kind of evenly like to space these points all the way around. So I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points here. So I'm going to kind of evenly space those around in kind of a circle. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it doesn't have to be anything perfect here, because it doesn't say it has to be equilateral or any of the sides be the same. So if I put these guys in together, if I connect them, okay, so that is a 9-sided figure. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I have a nonagon. All right, so just to make this absolutely perfect here, I have to put these letters in here. So I'm going to call this guy A, B, C, D, E, F, G, H, I. So those are all the points around that polygon. Notice it is convex. There's no points that are inside this guy. I didn't make any caves in there. So this is a convex nonagon. Number 6, we have to draw a regular concave triangle. So we can look and see that regular means that it has to have all the same sides and all the same angles. Concave means it has to have some type of a cave in it, and it's got to be a triangle. That means it's got to have 3 sides. So let's try to draw this. So I have a triangle, okay? So here's a regular triangle. But if I want to make a triangle concave, I might have to go something like this, and then kind of come in like that. Okay, let me erase that and draw that a little bit better for us. If I have to come in a triangle, bang, bang, bang. So this has these points out here. It kind of looks like a triangle, but then we have to ask ourselves, how many sides does this guy have? It has 1, 2, 3, 4. So is this still a triangle? No. So the thing is here is that a concave triangle is impossible. So this one is not possible. So your homework today is going to ask you some things, whether these statements are true sometimes, always, or never. So you have to ask yourself, can I draw that? So we can't draw a three-sided figure because this is a triangle. We can't draw that goes concave because then it would have more than three. All right, so this has to be convex. So kind of some tougher questions here. So this one is not possible to draw a concave triangle. All right, so it is up to you to work on that page 35 for homework for Monday. So please get that done today in class and have a good weekend. And we'll see you on Monday.